First of all, as was mentioned, all attendees are on mute. If you have a question, use the questions feature. We will have, after each presenter, one question, and then any remaining questions will be answered at the end. This is a very popular webinar, and as a result, NPPR is going to offer a discount for the attendees of this webinar as far as membership in the National Pollution Prevention Roundtable goes. If you want a professional membership, which is for an individual, there'll be a $50 discount. And for an organizational membership, a $150 discount. Membership in NPPR will allow you to receive notices of future webinars. We intend to have about 2 webinars per month. Some of the future topics include green chemistry, P2 results, and the new ISO 14001:2015 EMS standard guidelines. With that, I'm going to turn the webinar over to our host, Michael Simpson.
Good afternoon. Thank you all for joining us today for the webinar, The Future of Microplastics. I'd like to give thanks to the speakers for participating and providing information on microplastics. I would like to give special thanks to Susanna Vargas, a junior chemical engineering major at Cal Poly Pomona, who provided the energy and management skills to make this webinar happen. Without her, we wouldn't be here today. So thanks a lot, Susanna. This webinar is brought to you by the National Pollution Prevention Roundtable Research, Technology, and Energy Committee. I know that's a mouthful, but that's the committee I'm over for the NPPR. And we'd like to invite the audience to join the NPPR and specifically join my committee, the Research, Technology, and Energy Committee. We're doing some outstanding things in this committee. And one thing we get ready to launch real soon is called a Green Chemistry Manual. And this manual is for the layman practitioner person who actually goes out to companies and tries to get them to be greener through audits. And that's going to be coming out probably at the end of January. NPPR can be found at p2.org. Before there was green and sustainability as a popular hot words, pollution prevention was the mantra to move industry to a more benign way to produce and dispose of products. This year marks the 30th year celebration of the Pollution Prevention Act. So this is a big year for us. I'm Michael Simpson. I'm chair of the Research, Technology, and Energy Committee and an NPPR board member. I also work for the City of Los Angeles Clean Water Program. We plan to have another plastic webinar in March or April. We want to create a plastic working group. And if you want to be part of that group, please leave an email to jeff@p2.org. Today we have 3 expert speakers, and they're going to talk about legislation, industry, and academia regarding microplastics, and they'll be discussing what microplastics are, legislation solution, industry perspective, and the science of microplastics. So with that, I'll turn it back over to Jeff so he can introduce the first speaker. Thanks for participating.
Okay. Our first speaker is Sherry Mason. And Sherry, I'll turn it over to you.
All right. Well, thank you all for participating in this webinar and giving us an audience to share information through. I've been asked or tasked with giving you guys some introduction into what plastic is, and then more details with regard to my research on plastic pollution within the Great Lakes. So just to start us off, I want to say one word, just one word, plastics. Figured it'd be good to just kind of make sure everybody had a concept of what we mean when we use the term plastic. Here we're referring to synthetic, or in some cases semi-synthetic polymers. Like any polymer, these are composed of monomeric units which are attached in repetition to make your long chains. There are naturally occurring polymers such as DNA, RNA, your hair, your skin, all the proteins that make up your muscles and various enzymes within your body. So these are naturally occurring polymers. Many of us probably have pieces of paper sitting in front of us. Those are made from cellulose, the natural polymeric material of plants. But here we're talking about synthetic polymers, which were actually created for very altruistic reasons. They were created in order to replace the overuse of these natural materials, because polymers are really quite amazing molecules. They have very unique properties, and so we've been using them since the dawn of civilization, natural polymers, for various usage. But as the population on the planet increased, basically we were kind of overusing these natural materials, and so that developed the need for creating synthetic polymers. Polymers are great because they are very moldable, so you can make anything from, buttons to baby dolls to bottles out of them. They're very lightweight, so in terms of transportation, they're much easier to transport. And they're very durable, so that they can last for very long periods of time. Of course, these same properties are actually kind of what lead to the issues with regard to plastic pollution that I'll be talking about. Just kind of an overview of what the issue is with regard to plastic. Basically, the concern is that you have these very durable plastic materials that can be transported long distances, and under the action of sunlight and mechanical abrasion by wind and water and cars running over them, they can break into smaller and smaller pieces. These pieces in the water can absorb toxic chemicals. And then the concern is that these plastic particles can make their way into and up the food chain, ultimately into us, and basically be a vector or a means to move chemicals from the environment into the food web. So it's kind of the overview of what the issue is, but I want to just kind of focus in on what my research has been with regard to looking at plastic pollution within the Laurentian Great Lakes. There are 5 Great Lakes. I live along the shores of Lake Erie. Our research started in 2012, in which we did a survey starting in Lake Superior, sailing down into Lake Huron, and then into Lake Erie. This was the first time the open waters of the Great Lakes had been surveyed for plastic pollution. Based upon those results in 2012, we did a second survey of Lake Erie in 2013, and also went into Lake Ontario and Lake Michigan. So between the 2 years, 2012-2013, we have surveyed all 5 of the Great Lakes, and those are the data that I'm going to be presenting to you. How we survey the Great Lakes for plastic pollution, we use what's called a manta trawl. So it's an aluminum frame that holds a 333 micro mesh net and skids along the surface of the water. So all the plastics that I'll be talking about are those that are less dense than water and therefore float, and basically bigger than 1/3 of a millimeter, because that's the size of the mesh of our net. One of the questions that I frequently get is, well, why can't we just go out there and clean it up? So I always like to show some images of some of the samples when we bring them in. So this is one of our samples that was particularly filled with not just plastic debris, but you'll see, all of these little organisms. Those are all midge-fly larvae that we collect. So when we're out there and we're surveying, it's not like we're just picking up plastic. We're picking up life. And so it's not easy to extract plastic from the water without also extracting that life. And that, what makes a body of water alive is all of that life. So you can see the pieces of plastic within, this medium, but here's a piece of red foam, right? But there's a lot of life that's in here too. Same sample, looking at it from above, so that's that same piece of red foam. Here you have a piece of black rubber, blue plastic particle, piece of styrofoam that started to break apart into little bits. So we definitely collect plastic, but we end up collecting a lot of life too, and that's the point, is that it's really, once the plastic is in the water, separating the plastic out is not an easy task. What we do when we get our samples, we bring them back to the lab. We sieve them into 3 different size classifications. Within each size classification, we put them through a wet peroxide oxidation to basically oxidize all of the naturally occurring organic materials, and this leaves behind the synthetic polymers, which we then filter, and then looking at our filter paper we can pull out the pieces of plastic and we categorize them. So for example, this would be considered a pellet. This piece here would be a fragment. Okay, we also do fibers and lines and films and foams, so like styrofoam. So we have 5 different classifications of the plastics, and then we provide counts. Based upon the counts and the size and the length that we towed our net, we can extrapolate to how many plastic particles we collected per square kilometer, and this is referred to as the plastic abundance. So all of the numbers I'll be showing you with regard to our data are abundance, how many plastic particles we found per square kilometer. So looking at our 2012 data, this is the Great Lakes. Like I said, we started up in Lake Superior. The size of the dots, so each dot represents a sample, and the size represents, the larger the dot, the greater the plastic abundance. So we had 5 samples in Lake Superior, which showed slightly lower numbers on average than Lake Huron. I think that part of that is one, we only had 5 samples in Lake Superior. It was not an extensive study. I have 100 samples from 2014 that will provide us a much better insight into the plastic pollution within Lake Superior. But we were also happened to be closer to the shoreline in Lake Superior, whereas in Lake Huron we tended to go down the middle of the lake, and I think when we're closer to the shoreline we tend to see higher counts. But roughly those two Great Lakes actually showed very comparable numbers, 6,000 and 8,000 plastic particles per square kilometer on average. What really blew us out of the water in 2012 was the counts that we got out of Lake Erie. 90% of the plastic that we obtained in 2012 was extracted from Lake Erie. In some ways this isn't a surprise, right, because the water that we're sampling, or the plastics that we're sampling in Lake Erie, aren't just from the people who live around Lake Erie, although they certainly contribute, and Lake Erie is the most populated of the Great Lakes, but it's all the stuff that's flowing into Lake Erie from the other places. We had 2 samples out near where I live in Dunkirk, Fredonia, New York, that were especially high. Highest one was 460,000 plastic particles per square kilometer. That ends up being, for people who prefer square miles, about 1.1 million plastic particles per square mile. Looking at these numbers in more detail, so this is kind of digging into those counts. Along the top we have our different 3 size classifications, 1/3 of a millimeter to 1 millimeter, 1 to approximately 5 millimeters, and then pieces that are greater than 5 millimeters. And then we have our different classifications along the left-hand side, right? Our fragments, pellets, fibers, films, and foams. And what was really interesting to us from the 2012 was the fact that 81% of the pieces that we pulled out were actually in the smallest size classification. That was surprising relative to what has been seen in the world's oceans, and have lots of hypotheses as to why, but that was really interesting to us. It's basically the size of the particles, because the fact that they're so small makes them more easily ingested into the food chain. The other thing that really caught our eye was the fact that in 2012 the biggest contributor were these pellets, so these perfectly round spherical balls of plastic. So this is one of the samples, and then zooming in a little bit, just want to catch your, catch your attention to these round pieces of plastic. And what really caught our attention with regard to those is that typically we think of plastics photodegrading into smaller and smaller pieces, but when a plastic photodegrades, it's not going to form a perfectly round spherical ball of plastic. So these are something that would be emitted into the water supply as a round particle. I don't have time to go into all of our analysis, but we did a little detective work thinking about where these things might be coming from. For example, some people may be aware of like pellet guns now use plastic beads, but those are too big relative to these particles. So we thought of a couple of different options, and one of them being these body washes, facial cleansers that include microbeads on the front, and in the ingredients you'll see listed something like polyethylene, polypropylene, or polymethacrylate. So these are plastic pieces that are included into these products intended to be abrasives. These are some of these products without all of the cleaning materials, just the plastic particles that were included within those products, and then looking at them under a scanning electron microscope, so just a high-powered microscope. I do want to point out that what made us think of these were these perfectly round spherical balls of plastic that are very kind of eye-catching from a marketing standpoint, but actually the biggest contributor of plastic within these products are these fragments. These are actually what do the abrading more than the round spherical balls. It was kind of just that the balls of plastic kind of became the canary in the coal mine, if you will. They brought our attention to these products as potential sources and allowed us to kind of collect some evidence to support the fact that these may be contributing to the plastic that we're finding in the Great Lakes, comparing some of those plastic beads that we pulled out of the Great Lakes to what's in the product, just to kind of give you an idea of their similarity. Going into our 2013 data, this is one of our samples from Lake Ontario in 2013, just kind of an homage to the earlier image I showed you from 2012. Lake Michigan is our best surveyed of the Great Lakes to date. We collected 85 samples from Lake Michigan. Seasonal gyre develops on the southern end of Lake Michigan, so we kind of expected that we might see higher counts on the southern end, but actually it was fairly well distributed across the lake surface, on average 17,000 particles of plastic per square kilometer. We think the even distribution has to do with the fact that the residence time of water within Lake Michigan is 99 years. So aside from Lake Superior, Lake Michigan has the highest residence time of any of the Great Lakes. Lake Erie, and the triangles we're showing the data that we obtained in 2012. The circles are the data that we obtained in 2013, showing you just kind of the fact that, you know, these weren't statistical outliers. We continued to see very high counts in 2013 that supported what we collected in 2012. And then kind of like how Lake Erie blew us out of the water in 2012, Lake Ontario blew us out of the water in 2013. Almost every sample, with the exception of these two, as the water is making its way into the St. Lawrence Seaway, but the majority of samples within Lake Superior, Lake Ontario, really kind of blew us out of the water with regard to how high the counts were. Our highest count to date was 1.3 million particles of plastic per square kilometer, and that was collected outside of Toronto. I think one of the reasons that these counts are so high is we were circumnavigating the lake. We actually started up here in Montreal. We went down the St. Lawrence Seaway, and then we did a circumnavigation of the lake because of basically the boat that we were on. But regardless, in some ways it's not really a surprise that the counts on Lake Ontario would be so high, because again, it's not just what people from, who live around Lake Ontario are contributing with regard to plastic in Lake Ontario. It's all the stuff that's flowing into Lake Ontario from the other Great Lakes. So looking at our data kind of combined between the 2 years, again, size classifications and types. Sizes on the top, types on the left-hand side. The pellets on a whole weren't as prevalent within our 2013 data as they were within 2012, doing a sum total over all of the data, but still are contributing anywhere from 16 to 20% of the plastics that we find. Fragments are the biggest contributor. In many ways, that's really not a surprise, because if you think of the number of plastic items that we use that are bigger and would photodegrade, we would expect to actually find quite a bit of fragments with regard to plastic. But still, the largest size classification that's contributing to the overall plastic that we find are these smallest particles of plastic. And those are the big concern with regard to food web issues. Our hypothesis about these personal care products kind of contributing plastic into the Great Lakes led to an additional study that we've been conducting over the last year and a half, looking at wastewater treatment plants. So we actually sample the effluent that's coming out of various wastewater treatment plants. At this point, I have data for 6, although we have quite a few more than this, but this is some data that I wanted to share with you all, where I'm looking at discharge location rather than identify particular plants. per gallon, you don't see huge numbers of plastic, but if you consider how many gallons of water, so these are millions of gallons per day that each facility on average is processing. So while on an individual gallon basis, it's not a whole lot when you consider how many millions of gallons they are participating. And this is this column here is an annual flow rate, but when we do the calculations, we actually look on the day that we sampled how much their flow rate was on that day. And then we averaged over the, anywhere from 5 to 10 samples that we collected at the individual facilities. You can see quite a bit of plastic that could be emanating, that is emanating from these facilities. And then if we dig into those in terms of more detail, in terms of the types of plastic that are coming out, right? Pellets are coming out, so these personal care products that we were interested in looking at, they are they are contributing to the plastic that we see. Fragments are another contribution, and then fibers coming from synthetic clothes are also a contributor, a significant contributor. So kind of summing this all together, sources, basically the plastic that we find out in the water ultimately comes from us. It comes from consumer products. Some of it are these exfoliating microbeads that we see from personal care products. Some of it is photodegradation of larger plastic items. So these are some of these larger plastic items. That's actually a cigarette wrapper on the left-hand side. And some of it are, when we wash our synthetic fabrics, these microfibers that will actually be emitted or released from the material as we wash it. So, and with that, I think I've probably taken up the 10 minutes that I was allotted, so I want to thank people and ask for questions.
Okay. Thank you, Sherry. Two quick questions. One, understand that microplastics can absorb toxics. However, what about the reverse process of greater leachability of chemicals within the plastic, such as phthalates?
Right, yeah, and that's, I was allotted 10 minutes, so I didn't have time to really get into all of the details. This is a presentation that I normally give in an hour. But definitely things like phthalates, BPA, flame retardants that are frequently included within the plastics can leach out of the plastic once they're ingested or while they're within the body of water, and that's another concern. The only thing that we've done to date is actually look at the surface of the plastic for chemicals absorbing onto the plastic from the Great Lakes. So we focused in on PCBs and PAHs and did find elevated concentrations of these carcinogenic compounds on the surface of the plastics that we've extracted out of the Great Lakes.
Okay, thank you. And now we are going to go to Thyma Anjam with Environmental Advocates of New York.
Hi everybody, thanks for being here with us today. So I'm going to talk to you about microplastics, and I'm sure that I'll cover, I'll quickly cover some stuff that Sherry Mason talked about too. But Environmental Advocates of New York, we were founded back in 1969, about 46 years ago, and we are New York State's leading green watchdog. We have a network of 40,000 advocates, and we've been successful in many different campaigns over the years that have affected the health and well-being of all New Yorkers, from a bill that would require pesticides, the use of pesticides being reported, to a fracking ban really recently, a bill that would require the recycling of electronic waste. And in 2014, we were active in a microbeads campaign right here in New York. So today I'll be covering microplastics, whether or not they're harmless or harmful, and some alternatives and solutions that we've come across. So microplastics, like Sherry talked about, they're small plastic particles that make their way into the environment. And here, again, I just want to point out that we're looking at hundreds of microbeads in this little vial, and they come about in a couple of different ways. So plastic, which takes a lot of resources to make, like this plastic bag right here stuck in the tree, it starts off as one piece of plastic, and then it breaks apart into smaller and smaller pieces, amounting to tens of thousands of pieces of plastic. It will never fully break down. And it's hard enough to keep these big pieces of plastic contained. So imagine how hard it is to contain tiny microbeads, especially once they're out in the environment. And all of this plastic pollution contributes to the garbage patch that we see in the Pacific Ocean, a smaller garbage patch that we've seen in the Atlantic Ocean, and of course the pollution in the Great Lakes that Sherry talked about. In some cases, microplastics are created specifically for use in certain personal care items like face washes, soaps, and toothpaste. They're used as an exfoliant, and they're used in place of natural exfoliants like sea salt, oatmeal, and ground walnut shells. There are many manufacturers who use products with natural abrasives in them. You might be familiar with some of these, like St. Ives that uses the crushed up walnut shells or the peach pits. However, certain manufacturers still insist on manufacturing these tiny little particles. So microplastics and microbeads might seem harmless. They're pretty tiny, but it is their small size that makes them dangerous. It's easy to assume that they'll quickly go away, but plastic will never fully degrade. Animals will mistake these small plastic particles for food, as some turtles might mistake them for fish eggs, for example. And because of their small size, they're also going to escape treatment at wastewater facilities and end up being released into bodies of water. So it's estimated that a single product can contain up to 350,000 plastic microbeads, and these are either polyethylene or polypropylene beads. These are designed to be washed down the drain, and washing your face should not be an act of pollution. As we talked about, we know that tiny particles also come from other plastic waste. The example that I cited before was the plastic bag that keeps on breaking apart. It keeps on breaking into smaller and smaller pieces due to exposure from the elements like sun, wind, and water, but it will never fully break down. And added to that is the burden that comes from microbeads. Half of the plastic in oceans are microplastics. So now we're talking about plastics that are really pervasive in our environment. When we wash our face or brush our teeth with these products, these microbeads are washed down the drain. They're designed to be washed down the drain. And then they work their way into the sewer system, where they make their way past water treatment facilities because these facilities are not equipped to filter them out. And then they finally land in lakes and in other bodies of water, where along the way these plastic particles easily absorb toxic chemicals like flame retardants, PCBs, pesticides like DDT, and other industrial chemicals. And these harmful chemicals bind to the plastic particles. Microplastic particles are mistaken for food, and they've been found in fish, reptiles, mussels, and worms. It's also been shown that these toxics transfer to fish tissue. These toxics will continue to build as they travel up the food chain, which will impact the health of both wildlife and humans. And for example, here we have a lanternfish in the upper left-hand corner, and these little guys will mistakenly eat the tiny plastic particles. They are deep-sea plankton eaters who come to the ocean surface at dark to feed. They are a pretty common fish in our oceans and a major food source for larger game fish like mahi-mahi or tuna. And those fish are in turn caught and consumed by humans, like that little boy right there. So, you can see the look of concern that this little critter has on his face. So let's talk about what we can do. Well, there's no easy way to remove microplastics once they've been released. Since they don't degrade like natural materials do, they do persist in our environment for decades. Even if a filtration system was developed, there's no easy way to remove the plastic pollution from the phytoplankton and the zooplankton that are needed for the success of the water bodies. Even though some manufacturers have agreed to phase out the use of microbeads, there is no real timeline to do so. Setting goals legislatively will help manufacturers stick to their commitment to protecting the environment. And we need to ensure that these companies phase out the use of these plastic microbeads before more damage is done to the environment. We really need a fast timeline for removal, otherwise the industry will be passing the burden onto the municipalities who are going to have to pay to update their wastewater treatment facilities. In the meantime, we can look at alternatives. Sea salt, oatmeal, ground up walnut shells, coffee grounds, et cetera, et cetera. These are all really commonly used, and there are many products on store shelves that are already using these natural exfoliants. Microplastics are not essential in personal care products, and you know, I really question whether or not these microbeads have any effect on beauty or hygiene. So it's a little overwhelming to hear polyethylene and polypropylene and to be told to watch out what you're looking for in the store. So if you feel like you're having a hard time escaping microbeads, you can check out this app, Beat the Microbead, and it'll do your research for you. You can just scan a barcode in the store and it'll take care of the problem. So if you have any questions, please feel free to reach out to us. And thank you very much.
Okay, thank you, Simon. One question, actually two questions. One, do you have any statistics on the volume or weight of plastics per square kilometer or any other information like that?
I can definitely get that. I know that half of the plastic in the oceans comes from microplastics, and I know that there are some other facts and figures that are a little bit more specific, but I would have to dig them up.
Okay. And then another question, is there technology to filter or remove the plastics at the wastewater treatment plant level? Are you aware of?
I don't know if many municipalities have looked into that or if they're interested in looking into that, but I think that this is something that they're going to have to address, you know, in the future, especially if we're not successful in banning the use of these immediately. In terms of actual technology that's available today, again, I'm not sure, but I'd be happy to look into that further.
Okay. Great. Thank you. Before we turn over to the next presenter, I do want to repeat that we are recording this webinar, and it will be posted on the NPPR website next week. That's www.p2.org. So check the. Currently we're having some technical difficulties with the website, but hope to have those corrected, and this webinar recording will be, as I said, posted up on the website. And no, there's no charge or cost for this webinar. If you want to get the notifications of future webinars and also participate on the committees or work groups that Michael had talked about at the beginning, membership in NPPR, as an attendee of this webinar, you would receive a reduced first year annual membership if you're not already a member. Okay, so turning it over now to Homer Sway from Johnson & Johnson. Homer?
Okay, first some background. In 2012, some of you may be familiar with our safety care commitment. We launched that in 2012. We made a public commitment to remove or reduce a number of ingredients to provide peace of mind to our consumers and customers. In 2013, we added microbeads, and I think following that, Ken Zarker from Washington State, he asked me to join this roundtable, and I'm happy to do so. Thank you for Ken Zarker and the organizers for allowing me to talk about the science of microbeads. I'll be talking about what they are and how we use them and why we use them and some alternatives and what we know about the end of life for microbeads. Okay, so let me first start off by saying what they are not. In the Minnesota Pollution Control Center document, they feature this nice picture here, perfectly round particles. Those are not microbeads. Those are, in the business we call them breakable beads. What they are an encapsulation device. They're made of cellulose, thin layer of cellulose. Inside each of these breakable beads are vitamins or skin functional ingredients that will break upon contact. So those are not microbeads. In the 5 gyres report 2, very nice picture, but these are also not microbeads. They are simply the wrong size and the wrong shape. There's often references to perfectly spherical particles. As reported today, those are not microbeads. In fact, that's not what you want. A perfectly hard, round, spherical particle does not provide enough friction to perform as an exfoliant. They're not very good, so that we're not looking for perfectly round spherical particles, and they are not used in personal care. And also ingestion by fish, they are also not found. Microbeads are not found in any of the reports about fish ingestion. In fact, you see a little note there when you look and try to identify what the plastics are. It's very, very difficult to find polyethylene. Polyethylene is by far the only ingredient that's really used as a microbead. It's the only one that we use. And if you look at the statistics there, only one sample out of 504 showed polyethylene. And when I look at that, it's very difficult to say that was a microbead. I don't think that was a microbead either. So what are microbeads? They are low-density polyethylene. They're about 200 to 400 micrometers in width. They're all irregularly shaped. We want an irregularly shaped particle to promote exfoliation. But there's no sharp edges, and that's an important key feature, to having no sharp edges, because if you have sharp edges, there's a tendency to cut skin. That's not what we want to do for an exfoliant. So why do we use microbeads? I'm not sure how others use exfoliants, but within Johnson & Johnson, they're primarily used to support acne products, anti-acne products. Some statistics here about acne, about 3/4 of Americans 11 to 30 years old will get it at some time. About 17 million have acne at any one time. Right? So what we're trying to do here is trying to dislodge the cap in the pore just enough to allow the anti-acne medicine to get inside to treat the bacterial infection, which is P. acne. That's the whole idea on microbeads for our product line. Either in 2 products or in a combo product inside the anti-acne OTC medicine together. They both work fine. They work perfectly because they're low irritation, there are no sharp edges. They help to dislodge the pore, which I just mentioned. And very importantly, they're compatible with a large number of ingredients, including the medicines, the anti-acne medicines. We started looking at these in the early 2000s, and they became very popular in the late 2000s. And it wasn't until later, until we started doing clinical studies, that we understood this phenomenon about their ability to dislodge the cap, this clog, and help anti-acne products. Now, the question of wastewater treatment came up many times during the development. We asked the suppliers to provide evidence, and they provided pretty strong evidence here. They essentially seeded a wastewater treatment plant. They spiked it, and nothing came out the back end. And that was enough evidence, very convincing evidence, that there wasn't an issue here for wastewater treatment. But we were, even after we made our commitment in 2013, we were a little puzzled on all the discussions about wastewater treatment. There really was no controversy on the evidence in the environment. We just don't see them. I can't see them today. But we were curious why there was differing opinions on what happens during wastewater treatment. So we actually we asked Temple University to take a look into this. Now, we don't have any, we already made the commitment to remove them. So we were actually just interested in the science, what exactly was happening. And they provided some very interesting feedback to us. So it's very important for them to do the right analysis. They collected a bunch of samples and they looked at every particle and make sure it had the right size, the right shape, and the right FTIR fingerprint, that it fits exactly a microbead. So I think that was the best study that we've seen. But what they had told us was very interesting. Both in lab simulations and during wastewater treatment plants, the microbeads are instantly trapped. They're encapsulated by biomass. And whatever happens to the biomass, there goes the microbeads. They were able to show about 80 to 100% removal in the wastewater treatment process. I think whatever comes out is still trapped in the biomass. So, you know, whatever happens to the biomass following treatment will be the same thing for the microbeads. And the other discussion that we found was a lot of people were talking about fine filtration. This was a very ordinary wastewater treatment plant. It didn't have any special treatment treatment facilities or equipment. So the filtration doesn't really matter in this case. It's just wherever the biomass is handled is where the microbeads will go. And let me close off by alternatives. Yes, there are a lot of seeds and shells used. Unfortunately, that technology still has sharp edges. It still can cut the skin. So we prefer not to use those, especially for anti-acne treatment where the skin is already fairly irritated from the beginning. Minerals do the same thing. They also are too abrasive to the skin. Salts is the same way. We are having some successes with some waxes, plant waxes, but it's not a universal solution. Those have a tendency to interact with other ingredients, particularly the anti-acne medicine. So that's not a universal solution. We're having some success with biodegradable polymers, but still the jury's still out. We still have a lot of work to do. And ultimately, we're still looking for some new ingredients, especially with the medicines. Okay, and I'll take any questions.
Okay, thank you. Let's see. So first question, do photodegradable plastics break down into benign byproducts?
I cannot answer that. We're not looking at photodegradable plastics, so I'm not sure. Cannot say that one way or the other. That's not something we're looking at.
Okay. There is a growing interest in bio-based plastics. Do these fit in the category of biodegradable polymers?
They may. What we're looking at is enough evidence in marine and surface water biodegradation. So what I mean that is enough evidence that shows biodegradation following wastewater treatment.
What can you say? What biodegradable polymers you've looked at?
I cannot. Until we go commercial, please, I cannot.
I understand. Okay. Then let me open this up then to all of our panelists because there's some questions that go back to the earlier presentation. Let me just see. Okay. Are any of you aware that Illinois has legislation to ban microbeads?
Yes, of course. We are supporting that. I think that is already law passed last year.
Okay.
Yeah, but it doesn't take effect until 2019, and it allows biodegradable alternatives, although it does not define what biodegradable is. And so it's, I'm very happy to have seen it passed but I am concerned about some of the changes that were made in order to get it to pass so quickly.
Yeah, and this is Sima. I mean, I would say the same thing. You know, we're happy that that this issue was addressed through this law, but the timeline for removal should not take. It shouldn't be that long out. It shouldn't be that far out.
Okay. Next question. If spherical beads aren't microbeads, then what are they?
So I don't know what they are picking up. In our product line, spherical beads are the breakable beads. They're made out of cellulose and sugars. Those are the only ones in our portfolio. Perhaps Sami or Pam can comment. Or Sherry can comment, sorry.
Well, I respectfully disagree with you. I mean, I showed you pictures, SEM pictures. We've done analysis on those perfectly round spherical FTIR analysis, shown that they're polyethylene. They're microbeads. Now, are they doing the exfoliating? No. And in fact, the fragmented plastic particles are a bigger contributor to the plastic in these products than are the perfectly spherical little balls. But the perfectly spherical little balls tend to be colored and they tend to attract people to the product. I remember when these things came out, before I was aware of what those particles are, and you go in and you see these soaps with these little orange balls floating in a clear liquid, and it looks cool. You know, it's definitely a marketing tool, but yes, you are correct that a round piece of plastic is not going to exfoliate, and so that's why you have then the smaller fragmenty pieces. But to say that a perfectly round spherical ball of plastic that's included in these products, whether those their inclusion is intended to exfoliate or simply as a mark.
No, forgive me. The perfectly round spherical balls are the breakable beads.
Is incorrect.
Sorry, the perfectly round spherical balls that you see are breakable beads, and they're made out of cellulose and sugars.
Maybe in your product line, Homer, but there are other products out there.
I can't speak on other folks, other.
Right, I understand that, and certainly there are ones that are made out of cellulose, but you can't say that they all are. And we have verified the polymeric identification of the beads that we pulled out of the Great Lakes and that we pulled out of our wastewater treatment facilities that we've tested. And if they're plastic and they're round, then they're a microbead.
No, they're not. They're not microbeads in the sense of what cosmetic microbeads are.
Okay, let's move on to another question. I guess this is for you, Sherry. Were you looking at just municipal wastewater treatment plants, or did you also look at industrial?
We looked at most of the facilities that we looked at are actually mixed use, so there is some industrial effluent, but they are municipal. You know, for example, my neighborhood wastewater treatment facility, we have a number of food processing facilities in our area, and so they treat the effluent that's coming out of those. And in fact, my campus discharges, for example, their food waste into the wastewater pipeline. So they are processing effluent from some industry, but they are municipal wastewater treatment facilities.
Okay, so you didn't look at effluent from any plastic factories?
No.
Okay. Since this is the National Pollution Prevention Roundtable hosting this webinar, there's a question is, are there pollution prevention or reduction strategies in dealing with plastic pollution?
Ultimately, you've got to focus in on the source. You know, there was a question earlier about is there technology that could be installed at these wastewater treatment facilities And I tend to focus, instead of thinking, oh, let's focus billions of dollars on changing every single wastewater treatment facility in the entire nation in order to extract something, why don't we focus on just not putting it there to begin with? So ultimately, that's why, when I talk about the sources of the plastic that we're finding in bodies of water, ultimately the sources are us, which means the solution is also us, right? So we find ways to limit our use of disposable plastic items. We don't need plastic in our toothpaste. We don't need plastic in our face wash. So that's an easy change. And there are products, naturally occurring products on the market, that you can choose instead. You can refuse the straw when you go to the to get go to a restaurant and you get a glass of water. Frequently they'll give you a straw. You can refuse to buy plastic water bottles. You can bring your reusable bags to the grocery store so that you're not using plastic bags. Each one of these things are sending a clear message that we do not need items that are intended to be used on the order of minutes, made out of a material that literally has a lifetime of longer than a human, hundreds of years. And that's ultimately what we focus on with regard to, getting rid of what's, the sources of plastic into the water.
Okay. What is the state of research regarding the absorption of contaminants onto plastic particles and then transfer of those contaminants into aquatic life?
Well, there are a number of studies that have shown that plastics do absorb chemicals out of the water up to 1 million times greater than the concentrations that are actually found in the water itself. So they basically they absorb it onto the surface and they concentrate it. The focus right now with regard to the Great Lakes then has been on, are these plastics making their way into the food chain? And so we're in the process of doing a food web study right now and establishing the fact that yes, these plastics are making their way into the food chain. And then the next step in that process will be then, are they actually, the chemicals that are then on the surface, are they desorbed in the process? Now that's with regard to freshwater. Science is this topic, this area of plastic pollution, has been a topic with regard to saltwater for much longer than freshwater. And so with regard to saltwater studies, they have shown, especially Chelsea Rochman's work out of UC Davis has established that yes, these chemicals are desorbing from the plastics into the organisms and then creating issues with regard to the predatory abilities of the organism, their metabolism. Richard Thompson has done some great work out of England as well with regard to this. So it's being established that yes, they are acting as a means to move chemicals from the environment into the food web.
Okay. And last question, a couple of people commented that since there isn't a 100% removal of plastic at wastewater treatment plants, it winds up in the sludges. What has any research been done on that, and what the impacts to land applied sludge and the natural environment? Is anybody familiar with that issue?
Jeff, this is Homer. I'm not aware. I don't know.
Okay.
Not an expert here. Maybe that's something else we should add. At this point, all cosmetic manufacturers are removing them anyway. So.
I don't know of any studies, but the guess would probably be that they're, since they are not going to be biodegraded, that they will eventually, basically move off of the land into the water, right? Just like those plastic bags that you see accidentally getting released or any kind of plastic product that I walk around campus, I see plastic forks, I see plastic pens. Those get run over by cars. There's a rain event. It runs down the storm drain. It ends up being discharged into a local body of water. I mean, that's one of the main pathways that plastic makes its way into our water, is simply by accidental release and then running off into local bodies of water through storm drains. And so you could expect that probably the same kind of thing is happening with regard to rinsing out of the biomass that's then applied to farms and communities and rinsing into the water that way.
We're all a bit speculating here, though, aren't we? Is there a study out there?
Yeah, no, this is, I did state that, Homer. Yeah,
okay.
It is speculation. I don't know of anybody doing those studies, but we do know that this happens, right, in terms of a plastic bag blowing in the wind and making its way into the water, right, or things running into a storm drain and being discharged. So it's not completely illogical, right? It's just saying, well, if this is happening in this situation, it's probably also happening in that situation.
Yeah, of course, but a microbead is not a plastic bag.
No, it's not, but it can be transported.
Like other plastics can be.
Okay. Well, I want to thank our panelists for not only the presentations, but the excellent discussion following the presentations. And one more point I did want to make, that again, if next week we should have the recording of this webinar up on the NPPR website at www.p2.org. And if you're interested in becoming a member of the National Pollution Prevention Roundtable, please send me an email and I will send you the membership information. And with that, again, thank you everybody, and look forward to participation in the next webinar.